Hi students, I welcome all of you to this video number 7. In this video, we are going to see the interconnection of two ports. I am Karupaya from RMD Engineering College. In the previous video, we have discussed what is two-port network and how the two-port networks can be understood using the different parameters. The different parameters are Z parameter, Y parameter, H parameter, ABCD parameters. Okay, so using these different parameters, we can interrelate the input current, input voltage with output current, output voltage. In this video, I am going to explain how the two different networks can be connected in different form. In general, we have three different kinds of possible connection. They are nothing but series connection of two-port network, parallel connection of two-port network, and cascaded connection. That cascaded connection is also known as tandem connection. Okay. Here I am going to explain the first one, series connection of two-port network. Here I am taking two networks, N dash and N double dash. N dash is having the input current I1 dash, input voltage V1 dash, output current I2 dash, output voltage V2 dash. Similarly, N double dash is having the input current I1 double dash, input voltage V1 double dash, output current I2 double dash, output voltage V2 double dash. Here I am going to connect these two networks in series connection. The first one is series connection. How I am connecting the series I am making the series connection, that is nothing but if I have two voltage sources, for example, this is for our understanding I am saying, if I have two voltage sources like this, how can I connect in series? That is nothing but I will connect plus minus plus minus plus in this way. Okay, so plus will be connected with minus, similarly plus will be connected with minus, so that I will get the overall voltage will be the addition of summation of all these voltages. Just remember this to so that you can easily connect these two networks in series. Okay, we know that this is positive terminal of the first network and this is negative, and similarly this is positive terminal of the network and this is negative. Similarly, output side, this is positive and this is negative of the second network. I am going to connect the positive of the second network with the negative of the first network, and similarly the negative of the output side of the first network is connected with the positive of the output side of the second network. This is called series connection. Okay, so now I can consider this as a single network inside which I am having two networks, they are connected in series. Okay, now forget what is there inside. Okay, I am having a network which is having input side positive negative, output side positive negative, so that for this I can give the input current is I1 and the input voltage is V1. Okay, input voltage between the positive terminal and negative terminal. I1 is flowing inside through the positive terminal. Similarly, from output side, the output side, I am having the output current I2 and output voltage V2. Now I am going to relate this I1 V1, I2 V2 with the inter parameters. Okay, now in this, if I connect the networks like this in series, this is called series connection. In this series connection, simply I can add the Z parameters. Okay, the Z parameters of the networks are getting added. Similarly, for parallel connection, y parameters are getting added. For cascaded connection, the ABCD parameters are getting multiplied. The reason why I am saying all these three things here itself, you have to remember these parameters. What will happen based on the connection? What will happen to the parameters? You have to remember so that you can easily solve the 2 marks and simple problems. Okay. So here, for the two networks, let us take the Z parameters of the network N dash. Z parameter of N dash be Z11 dash, Z12 dash, Z21 dash, Z22 dash. And similarly for N double dash, it is be Z11 double dash, Z12 double dash, Z21 double dash, and Z22 double dash. Okay. So what I said, the Z parameters of the networks are getting added. Okay. So what I am going to prove, the Z parameter of the overall network Z parameter of the resultant network or overall network, that is nothing but the red color box. B Z11, Z12, Z21, Z22. Now I am going to relate this one with this one. Okay. So for series connection, the voltage will be, for series connection, the voltage will be getting added. So V1, that is nothing but the resultant voltage, input side voltage, that is nothing but that is equal to V1 dash plus V1 double dash. The input voltage of the first network, input voltage of the second network, they will be added so that I will get the resultant voltage, input voltage. Similarly, output side V2 equal to V2 dash plus V2 double dash, and the current will not have any changes. Why? Because the network is connected in series, so the resultant current will be same, and the current will be I1 equal to I1 dash, that will be equal to I1 double dash. Similarly, output current I2 equal to I2 dash, that is equal to I2 double dash. Okay. Now for the network, first network, the Z parameter equation, of N dash, that is nothing but V1 dash equal to Z11 dash I1 dash plus Z12 dash I2 dash, and V2 dash equal to Z21 dash I1 dash plus Z22 dash I2 dash. Okay. Now similarly for second network, Z equation for the second network N double dash. For that, V1 double dash equal to Z1 double dash I1 double dash plus Z12 double dash I2 double dash. Similarly, the second equation, V2 double dash Z21 double dash I1 double dash plus Z22 double dash I2 double dash. Okay. Now when I connect these two networks from the equation 1 I can add V1 equal to V1 dash plus V1 double dash, so that I can add V1 dash and V1 double dash, so that I will get V1. Now therefore V1 equal to Z11 dash I1 dash plus Z12 dash I2 dash plus V1 double dash is Z11 double dash I1 double dash plus Z12 double dash I2 double dash. Now see the equation number 2. Here I1 equal to I1 dash equal to I1 double dash, so that I am going to replace I1 dash I1 double dash by I1. Similarly I2 dash and I2 double dash is replaced by I2, so that I can take those terms separately. The resultant equation is Z11 dash plus Z11 double dash into I1 plus Z12 dash plus Z12 double dash into I2, that is equal to V1. Similarly, I can write the second equation V2 equal to V2 dash plus V2 double dash. I can add these two equations, and the resultant equation will be V2 equal to Z21 dash plus Z21 double dash into I1 plus Z22 dash plus Z22 double dash of I2. Okay, now the resultant equation, I can write this one as V1 equal to Z11 I1 plus Z12 I2, and V2 equal to Z21 I1 plus Z22 I2. Okay, that is nothing but in matrix form Z equal to, I am writing the coefficients alone. We know that Z equal to Z11, Z12, Z21, Z22. Therefore it is nothing but Z11 dash plus Z11 double dash, that is Z11, Z12 dash plus Z12 double dash, Z21 dash plus Z21 double dash, Z22 dash plus Z22 double dash. This is the resultant Z parameter of the series connection of two port networks. And therefore the Z parameters of the series connection are the sum of Z parameters of the individual network connected in series. Okay, the second one is parallel connection of two port networks. If you understand the series connection of two port networks, then it will be very easy to understand the parallel connection of two port networks. In series connection, the Z parameters are getting added. In parallel connection, the Y parameters are getting added. In series connection, the voltage, that is nothing but V1 and V1 equal to V1 dash plus V1 double dash. But in parallel connection, the current will be added. The voltage will be same. V1 equal to V1 dash, and that will be equal to V1 double dash. But current I1 equal to I1 dash plus I1 double dash. Okay, you have to understand this one. This is the difference between the series connection and parallel connection. How I am going to connect the two port networks? Here I am taking the networks, the same networks, N dash and N double dash, and their parameters are I1 dash, V1 dash, I2 dash, V2 dash. For N double dash network, the parameters are I1 double dash, V1 double dash, I2 double dash, V2 double dash. So how we will make the parallel connection? That is nothing but, if we have two sources like this, positive is connected with positive and negative is connected with negative. That is nothing but, this is called a parallel connection, right? Now this is, these two sources, they are connected parallel. In the same way, here I am having positive, negative, positive, negative. Similarly, output side, positive, negative, positive, negative. So I am going to connect the positive with positive, negative with negative. Okay. So positive I am taking and positive. This one is positive. Similarly, the negative I am taking and this is the negative. Now this is nothing but two ports, the resultant of input ports. And similarly, output side, positive I am taking and I am connecting, that is one port, and negative, that is another port. Okay. Now the resultant network is having what? Assume that this is the network. We don't know what is there inside. So this is the network N. For that, the input current is I1 and input voltage is V1, positive, negative. And similarly, output side, the output current is I2 and output voltage is V2 between two terminals. Okay. But in parallel connection, what will happen? V1 equal to this way, V1 equal to, this is connected with V1 dash, therefore it is same. And similarly, this V1 is connected here also, that is equal to V1 double dash. Similarly, output side, V2 equal to V2 dash, V2 double dash. So V2 dash, that is equal to V2 double dash. The voltages are same in parallel connection. But what about current? Here I is splitted, I1 is splitted into I1 dash and I2, I1 double dash. Therefore I1 equal to I1 dash plus I1 double dash. Similarly, output current I2 equal to I2 dash plus I2 double dash. And we know the Y parameter equations, they are nothing but Y parameter equations I1 equal to Y11 V1 plus Y12 V2 and output current I2 equal to Y12 V1 plus Y22 V2. This is Y21. Okay. For here I am taking N dash so that all the parameters will be having I1 dash, Y11 dash, V1 dash, Y12 dash, V2 dash, I2 dash, Y21 dash, V1 dash plus Y22 dash, V2 dash. For the second network, all the parameters will be having the double dash. Okay. Now I am going to write this equation again. For that I will take these two parameters. So now the resultant parameter equation will be I1 equal to, I will take this one I1 dash, that is nothing but Y11 dash V1 dash plus Y12 dash V2 dash, that is first equation, plus I1 double dash, that is nothing but what? Y11 double dash V1 double dash plus Y12 double dash V2 double dash. Okay. Now we know that V1 equal to V1 dash equal to V1 double dash. So I am substituting in the place of V1 dash and V1 double dash, I am going to write V1 and I am taking that one as common term. So the resultant equation will be Y11 dash plus Y11 double dash of V1. Similarly, Y12 dash plus Y12 double dash of V2, that is equal to I1. In the same way, the second equation can be written as I2 equal to y21 dash plus y21 double dash of V1 plus y22 dash plus y22 double dash of V2. In the matrix form, I1 I2 equal to y11 dash plus y11 double dash, y12 dash plus y12 double dash, y21 dash plus y21 double dash, y22 dash plus y22 double dash, and the variables are V1, V2. Now this is nothing but what? Y parameter matrix. So y11 dash plus y11 double dash, y12 dash plus y12 double dash, y21 dash plus y21 double dash, y22 dash plus y22 double dash. Okay, what I told you, in parallel connection the y parameters are getting added. Okay, so if I know the y parameter matrix or y parameters of n dash and y parameters of n double dash for the parallel connection, that is nothing but for this red color box. Consider this one as a single network which is having V1 I1 V2 I2. We don't know what is there inside. Okay, now that is a new network. Okay, what is the resultant network will be having the y parameters, that is nothing but y equal to this one. The third one is cascade connection of two-port networks. When two ports are connected in cascade, we can multiply their individual transmission parameters to get overall transmission parameters of the cascade connection. Okay, here I'm having two networks, the same two networks, n dash and n double dash. How we are making the cascade connection, that is nothing but I'm going to connect the output of this network with the input of this network. Okay, this is called cascade connection. Now what will happen? This output is nothing but output of n dash is nothing but V2 dash, that is equal to V1 double dash, input of the second network. Okay, similarly the output current I2 dash will be equal to the negative sign of I1 double dash. Okay, and assume that these two networks, they are connected in cascade and we have as a single network here. Okay, now the output of the total network is nothing but V2 and input of the total network is V1. Similarly, the input current is I1, output current is I2. Therefore, V1 equal to V1 dash, V2 dash equal to V1, here input of the overall network is equal to input of the first network. Output of the first network is equal to output voltage of the first network is equal to input voltage of the second network, and output of the second network, output voltage of the second network is equal to output voltage of the overall network. So that is nothing but V1 equal to V1 dash, V2 dash equal to V1 double dash, V2 double dash equal to V2. And what about current? Input current I1 equal to I1 dash, I2 dash equal to minus I1 dash, I1 double dash, I2 double dash equal to I2. So the ABCD parameters for N dash network is nothing but A dash, B dash, C dash and D dash. For n double dash network, the parameters are a double dash, b double dash, c double dash and d double dash. Now the resultant network is n. For that the parameters are a, b, c and d. Okay. Now the ABCD parameter equations for n dash network is v1 dash equal to a dash v2 dash plus b into minus i2 dash, this is b dash, and i1 dash equal to c dash v2 dash plus d dash minus i2 dash. Okay, this is for n dash network, and for n double dash network the same equation is repeated with double dash. v1 double dash, a double dash, v2 double dash plus b double dash of minus i2 double dash. Second equation is i1 double dash, that is equal to c double dash v2 double dash plus d double dash of minus i2 double dash. Okay, and for the overall transmission parameters, overall ABCD parameters of the cascade connection can be written as, in matrix form I am writing v1 i1, that is equal to, here we know what is v1. v1 is v1 dash, v1 dash and i1 is i1 dash, that is equal to a dash, b dash, c dash, d dash into v2 dash minus i2 dash. Okay, now that is equal to the same a dash, b dash, c dash is repeated, and what is v2 dash? That is nothing but v1 double dash, and what is minus i2 dash? That is nothing but i1 double dash. And we know what is, this is nothing but the transmission parameter of the second network. Therefore it can be written as a double dash, b double dash, c double dash, d double dash into v2 double dash minus i2 double dash. Okay, now we know what is v2 double dash. v2 double dash is v2 and i2 double dash is nothing but i2. So here I can write v2 minus i2. So v1 i1 equal to v1 i1 equal to, we should have a, b, c, d v2 minus i2. Okay, if I equate this, I will get the transmission parameter, that is equal to a, b, c, d, that is equal to a dash, b dash, c dash, d dash into a double dash, b double dash, c double dash, d double dash. Okay, so now what I told you, when two ports are connected, this is port 1 2 port network, this is another 2 port network, when two ports are connected in cascade, we can multiply their individual transmission parameters to get overall transmission parameter of the cascade connection.